Okay, we just talked about the triangle proportionality theorem and the converse of the triangle proportionality theorem. And the last two things that we're going to talk about in this section, one of them is called the transversal proportionality. Transversal. Let's go back to chapter 3 and remind yourself what is a transversal. Transversal is any line that intersects two or more parallel lines. So this one says if three or more parallel lines intersect two transversals. So we have three parallel lines and we have two transversals. Here's one transversal and here's one transversal. Again, a transversal is a line that hits goes through two or more parallel lines or something like that. Okay, then they're going to divide the transversals proportionally. So that means if this one was 1, 2, 3, and this one was 2, 4, what do you think this one's going to be? Well, you could set up a proportion. You could say 2 over 3 equals 4 over x. Cross multiply, and you're going to get that x equals 6. So that's basically what the transversal proportionality theorem, or corollary, excuse me, says. So what we're going to do is we're going to have fun pictures that look like this. And suppose that an artist decided to make a larger sketch of the trees in the figure AB equals 4.5, BC equals 2.6 inches, CD equals 4.1 inches, KL equals 4.9. We want to find the last two. So if we wanted to find two segments, we're going to set up two different proportions. I'm going to call this X, and I'm going to call this Y. Okay, so to find X, here's the information they do give us. This, we can use this with this, and we know that this goes with this. There's lots of ways you guys can set up your proportions. I'm going to say 2.6 over 4.5 equals x over 4.9. I like to go from the same side. You could say that 4.5 over 4.9 equals 2.6 over x. Either way, when you cross multiply and divide, I'm going to get 4.5x equals 12.74. Same thing over here if you cross multiply, and then if you divide by what? By 4.5, you're going to get that x equals about 2.83 inches. So you're going to do the same thing for y. So y, you're going to use 4.1 instead of 2.6. So over here, I'm going to say 4.1 over 4.5. 4.1 over 4.5 equals y over 4.9. And then you cross multiply and solve again. If you don't like to do that proportion that way, you could say that 4.1 over y equals 4.5 over 4.9. So these are just two of the ways that you could set up your proportion. Either way, you cross multiply and solve. So 4.1 times 4.9, oops, is 20.9, and then divide by 4.5, and we get y is about 4.64 inches. All right, so when they ask you for two different segments, you have to do proportions twice, and you set it up very, very similar. Okay, that's the transversal proportionality corollary. So the same thing. This is the exact same thing. I want you to solve this one and see if you can figure out what x equals and what y equals. Then x is we could say x is LM and y is MN. So if I wanted to do it, I would say 1.4 over 2.4 equals x over 2.6 and solve. For y, I would say 2.2 over 2.4 equals y over 2.6. That's how I would set them up. You don't have to if you don't want to. There's other ways. Okay, last one. Everything that we've talked about, the last three, culminate and lead us to the triangle angle bisector theorem. And this one says an angle bisector of a triangle divides the opposite sides into two segments whose lengths are proportional to the lengths of the other two sides. So triangle angle bisector theorem. This is how in a proof, if we do proofs, this is how we could title it in a proof. So what this means is if you have an angle bisector, meaning these two angles are going to be cut. Let's say this side is 2 and this side is 4 and this side is 3. We could set up a proportion to figure out how long DC is. So you could say 2 over 4 equals 3 over x. Cross multiply, and you'll get that it's 6. All right, and yeah, so that's it. Triangle angle bisector theorem. Yeah. Okay. So for that one, if we have angle bisector, check. We know that these two triangles are going to be proportional. So you could say x minus 2 over 32 equals x plus 5 over 40. That's one way you could write it. And then cross multiply and solve. So 40 times x minus 2 equals 32 times x plus 5. And then you'd have to distribute and solve. This is just a simple algebraic multi-step equation. Okay? Okay, I'll do this one with you guys. Okay, so 40x minus 280 equals 32x plus 160. I'm going to subtract, and I'm going to get 8x. I'm going to add, and I'm going to get 440. And then I'm going to divide both sides by 8. And I'm going to x equals 55. All right? Try this. If you did, let's see, if you set up your proportion like this, would you get the same results? Try that. See if I'm right. I'm going to say yes, you can. Okay, and then the last one, AC and DC. Oh, wait, did I figure out? Oh, sorry, we didn't finish this question, huh? I solved for x. Was I done? No, go back and find out what PS and S are. So if you plug this in, 55 minus 2, this would be 53. And 55 plus 5, this one would be 60. So this is your final answer. Now you can do your happy dance. Okay, last one. Same thing, we have angle bisectors, so we know that these two triangles are going to be similar. So you could say 8 over y minus 2 equals 4.5 over y over 2. You could also say 8 over 4.5 equals y minus 2 over y divided by 2. It's up to you. These are going to be the same thing, because either way, when you cross multiply, you're going to get 8 times y divided by 2 equals 4.5 times y minus 2. And if sometimes the fractions scare people, 8 divided by 2 is just 4, so this would be 4y, and this would be 4.5y minus 9. Move the y's to the same side, and you get negative 0.5y equals negative 9, and then y would equal 18. Not done yet. We want to plug them in. 18 minus 2 is 16. 18 divided by 2 is 9. So these would be our final answers. All right, so we learned 4 things. What I want you to do in your notes is to draw a picture. Draw a picture, because you know me and my pictures, for each of the 4 things that we learned today. And I'm going to look at them tomorrow. Hooray!